Good morning, class. Today we're going to study the Pythagorean theorem. Many years ago, a Greek philosopher discovered an amazing fact, that if a triangle had a right angle at 90 degrees, and you made a square on each of the three sides, then the biggest square had the exact same area as the other two squares put together. That was called the Pythagorean theorem. How can we use the Pythagorean theorem in our everyday lives?
To measure TVs.
To make sure your foundation forms a square.
To take down trees?
That's right, class. We can do all three of those things. Right triangles are everywhere, and where there is a right triangle, the Pythagorean theorem could be used. The Pythagorean theorem has been used in many ways, including playing baseball, constructing buildings, or even removing trees. Before the existence of rulers and protractors, the Pythagorean theorem is how builders made perfect 90-degree angles. Today, we will be studying how to find the length of a third side of a right triangle given the other two sides. We will be able to use the Pythagorean theorem to find the area and the perimeter of right triangles when the length of one side is unknown, and we'll be able to apply the Pythagorean theorem to real-world problems. First, we're going to go over a little bit of vocabulary. As I said, a right angle is any angle that is exactly 90 degrees. The angles of a square are all right angles. A right triangle is a triangle that has exactly one right angle. And the hypotenuse of a triangle is the longest side of a right triangle. It is also the side that is opposite of the right angle. This is a right triangle. The hypotenuse is found by drawing an arrow from the 90-degree side angle to the side directly opposite. In the Pythagorean theorem, we label this side as C. The other two sides, called the legs, are the two sides that touch the 90-degree angle. In the Pythagorean theorem, we label them A and B. It doesn't matter which order they're in, you just label them A and B. The formula for the Pythagorean theorem is A squared plus B squared equals C squared. We're going to do a practice problem with that formula right now. If I have a triangle whose legs are 3 and 4, and I use the Pythagorean theorem with C squared equals A squared plus B squared, you put the 3 and the 4 in for the A and the B. Then you square the 3 and square the 4. You get 9 and 16. Add those two together and you get 25. Then you take the square root of the C squared and the 25. The square root takes away the square on the C. That leaves you with C is equal to 5. The triangle 3, 4, 5 is a common triangle when used in building. A builder that does not have a protractor or a right side will use this formula. They measure 3 feet from one wall, 4 feet from the other wall, and then they measure diagonally. It should be 5 feet. That's how they know that it's perfectly square. Let's try another problem. Our second problem, this time we have a leg that's 12. One leg, A, in this case A, is not labeled, and our hypotenuse is labeled at 13. We start with the same formula. C squared equals A squared plus B squared. Put in our numbers. Our hypotenuse was 13, so we put the 13 in for C. Gives us 13 squared. Because A was unknown, we leave it as A squared. And then we put the 12 in as 12 squared. Take the square of 13 and you get 169. If you take the square of 12, you get 144. And then you leave the a squared alone for now. The next step, you have to move the 144 to the other side of the equation. Because it's added on to the a squared, you have to subtract it from that side, leaving you with 0. What you do to one side of the equation, you must do to the other side of the equation. What you're left with is 25 equals a squared. And just like the problem before, your next step is to take the square root of both sides. The square root, again, gets rid of the square on the a, and it leaves you with an answer of a equals 5. We'll try one more problem. Tanya runs diagonally across a rectangular field that has a length of 40 yards and a width of 30 yards, as shown in the diagram. What is the length of the diagonal that Tanya runs? In this case, the length would be 50